All right, page 5 of lesson 5, we're going to talk about projectiles and labeling our key points here. So number 1, if a projectile is fired straight up from the ground with the initial speed of, you can aim things straight up, but they're going to kind of drift and then come back down. So I wouldn't pay so much attention towards straight, but it's going to go up. And the height in feet after 1 second is given by the following equation. So notice it's from the ground, so you're kind of missing your C. The C in these type of equations is, I refer to the start height. So if it's from the ground, it is literally on the ground when it starts, which means it's on the ground when it gets shot up, okay? And then it says find the time the projectile reached its maximum height. So we're looking for its vertex here. And this y is going to be the maximum height, okay? And the time it takes to get there is going to be there. So these are going to be time and height, okay? So let's see. I need my, need my T. They're going to use T. So time it takes, vertex formula. It's always where I start for a minute and a max. I didn't write it down. A equals negative 16, B equals 96, C equals 0. All right, so negative B is a positive 96, so negative 96, 2 times A is negative 16. So negative 96 over negative 32, and negative never negative is going to be a positive. It turns out to be 3 seconds. So it takes 3 seconds when it's fired up from the ground to get to the top. It takes 3 seconds. So this is my x-axis. This is my y-axis. So this pot right there, that's at 0. At 0 time on the ground, 0 seconds have gone by. I'm about to fire. When I fire, it takes 3 seconds. 1, 2, 3 seconds to get to this height. What is that height? So we need to find the height at 3 seconds. And that goes back in the original. Everywhere there's an X or a T, we are going to put a 3 and crunch out the numbers here. Don't forget orders of operations say do the square first. So h of 3 equals 144 feet. All right, so that's 144 right there. Okay, that's the 3 seconds. If it takes 3 seconds to get all the way up here, guess how much, where this is right here? 4, 5, 6 is where I expect my intercepts to be. I expect my intercepts to be 0 and 6. So we're going to come up with some math for that. But right now it says, what is the height of the projector after 2 seconds? So I expect it to be here somewhere, right? Is where I expect 2 seconds to be. Let's find out mathematically. So what is the height? In other words, the height when the time is 2. So h of 2 means put the 2 in. You have to be ready to answer whatever questions they ask about this function, okay? So this is going to come out to 128 feet. So at 2 seconds, I don't know, we can get there, 128, right? That means at what, 4 seconds? So this would be 2, 128. So 4 seconds, it'd be coming back. It would have reached its height and it's coming back down. So this is 2 times this projectile will be at 128 feet. Okay, and then it'll come back down at 6 seconds back down to the ground. So what time is the projectile? What time is the projectile 80 feet from the ground? So that's even lower. So we expect it to be between 0 and 2 seconds. So let's find that out. So it's giving me a height. This is 80 feet, so it's giving me an h of t of 80. So that goes here, okay? And then the rest of the problem, oops, what time? I am solving for t. All right, and how do you solve a quadratic for t? You need this to be 0, so I need to move this to the other side. Okay, once you're there, you can, I don't know if it's divisible by 16, but let's use the numbers whole. So this is going to be, I definitely wanted to use the quadratic for this. I bet I could take 16 out, but that's okay. Let's just do it as is. So negative b plus or minus square root of b squared minus 4 times a times c 2 times a. All right, this is going to be t equals negative 96 plus or minus, what is my discriminant? 96 times 96 minus 4 times negative 16 times negative 80. I did this before, so this should come out to that number. And this is over negative 32. Now this is, we need to crunch all these out. Apparently the square root of 4096 is 64. That's a nice pretty even number. So this is going to come out to 1, believe it or not. And then negative 96 minus 64 over negative 32 is going to come out to 5. So it turns out it's exactly here. So at 1 second, this is at 80 feet. And it's going to go all the way up and then come all the way back down. And because these are parabolas, isn't this interesting? I mean, would you think that it goes down as fast as it goes up? It does. According to this, 5 seconds, it will also be at 80 feet again, right? So there, it turns out there are 2 answers to this. 1 second, and at 5 seconds, it will be at 80 feet. Okay. What time will it hit the ground? Well, what time do you expect it to hit the ground? I expect it to hit the ground in 6 seconds because that's what my graph shows me, but let's do the math and prove it. Ground is code for tell me when it hits the ground at 0 height, right? 0 inches. So 0 gets put here. And we're solving for t when that happens. So my a, oops, it's a t. My b is 96. So negative 96 plus or minus, do this again, 96 squared. Minus 4 times a times c, which is 0 now, okay? Going to the ground, height, 2 times negative 16. So this is going to be negative 96 plus or minus the discriminant. This whole part of this is 0. So what is 96 times 96? Let me just double check that in my calculator. Yep, okay. So that's going to be, oh, right. So of course that had to be 96 because this is going to come out like this. So this is going to be, one of the answers is going to be 0. So t equals negative 96 plus 96 over 32. There's my 0. And then 96 minus 96 divided by negative 32 is where your 6 is going to come in. So there are my two intercepts at 0, 0 and 6, 0 are my x-intercepts. Okay? This 0, 0 is also what? The 0, 0 is also my y-intercept, right? That's where that's going to hit. If we can check that, because y-intercepts have an x of 0, right? So y, or h of t, would be negative 16 times 0 squared plus 96 times 0. So that's definitely going to be an h of t is 0. Okay, so that's my y-intercept and my x-intercept at 0, 0. Okay, so look at all the things we can answer now. This bottom one is what it's going to be an interesting one. I put this on here so you can see what happens when you only need one answer for something. So here's a bridge, throwing a rock off. This is the equation. Right there is where the bridge is at on my y-axis. Okay? So this projectile is starting at 800 feet high on my y-axis. When is it at 300? When is it at 300? So it needs to solve for t. So that means h is 300 is what they're giving you. Okay, so 300 equals negative 16t squared minus 20t plus 800. All right, I need 0 on one side, so I need to move this over. Okay, definitely want to do the quadratic formula for that. So t is negative b, so negative 20 2a and plus or minus square root of negative 20 squared minus 4 times a times c. So that's going to be 20 plus or minus square root, I did this before, is 32,400. Okay, negative 32. All right, so apparently the square root of this big, huge number is 180. Then something interesting happens. So t is going to be 20 plus 180 divided by negative 32, and t is going to be 20 minus 180 over negative 32. Now look at the picture. I'm only going to have one time when this hits the ground, wherever the ground's going to be. I'm only going to have one time. This is the y-axis. So everything else, all the other numbers are going to be on the negative side. So we don't really want to go there. In fact, when I crunch this out, notice that the top's going to be positive and the bottom's going to be negative. So this comes out to a negative number. And that makes no sense when we're talking about time. Okay, so that's not the one I want. But this one's going to turn out to a negative number because the negative 180 is there. Plus 20 divided by negative 32, this is going to come out to 5 seconds. So think about this. If this is where, let's say this is 500 feet, 400 feet, 300 feet, right here at 5 seconds after tossing this off a bridge from 800-foot bridge, 5 seconds later, it will be at 300 feet. Okay? It says, what is the height when it's at 4 seconds. Where do we expect it to be? We expect it to be back up here somewhere, right? After thrown. So it needs to be farther up and a little, notice this is going to be a little this way. To get a lower number than 5, let me move this over a little more. 4 is going to be back over here, and the height will be higher because it's on its way down, logically speaking. So I think if you draw your drawings, just a little sketch helps you understand whether your answers make sense or not. It's important. And it helps you understand the math, I think, with the picture. So what's this code for? If it's asking the height and it gives you a time, this means the time is 4. So we're looking for, if this was a function, it'd be h of t of 4. So h equals, we're going to go ahead and put the 4 in, negative 16. This one wasn't in function form, so I don't need to put the 4 with the h. I just need to put it in here. Okay, so this is negative 16 times 16. So this is negative 256 minus 80 plus 800. So apparently that's going to crunch out to 464 feet. So right here, 464 feet, right where we expect it to be, kind of between, certainly on its way back up. So when you throw it down, 4 seconds after you've thrown it off the bridge, it will be at 464 feet. Another second later, it'll be down to 300 feet. So it didn't actually ask you when it could get to the ground, but it certainly could if it wanted to, and you'd know how to do that. You'd put a 0 in for the height, right? Okay, do the rest on another video.